Um, Hello everyone. My name is Zhenhua. I'm a PhD student from Chalmers. Today I'm going to talk about how stormwater ponds for road runoff contributed to the aquatic biodiversity. Roads are widespread in modern society. They play a significant role in achieving economic development and contributing to the overall performance and the social functioning of the community. Although roads make a great contribution to the economic growth and bring important social benefits, they have dramatically changed the landscape and affect the environment and ecosystems in a number of harmful ways. Several adverse effects can be resulted from roads. For example, roads can change hydrological processes through the increased imperviousness of surface and loss of green space. In the areas covered by pervious surface, rainwater can infiltrate into the unsaturated soil layers, while impervious surface alters infiltration rates and increases the runoff velocities. Thereby, the transformation from pervious to impervious surface encourages rainwater to flow as surface runoff instead of infiltrating into the ground, and increase the frequency of floods. So this is a consequence of changes from pervious to impervious surface, and a car is remained stranded in the flood water of highway. Another effect can be resulted from road is habitat fragmentation. It can result from animals not being able to cross the road without being killed. It's especially the case for amphibians because amphibians migrate between wetlands and upland habitat. This graph showed that a poor frog was killed by the car on the road. In addition to the changes in hydrological processes and habitat fragmentation, roads can also be the conduit for pollutants into the environment, such as polycyclic aromatic hydrocarbons, metals like copper, zinc, lead, arsenic, road salt, and phosphorus. They originate from a wide range of sources, such as vehicles, road surface together with infrastructure, and use of the icing agent during winter. Several studies have demonstrated that chemical pollutants may have adverse effects on aquatic organisms, and they may kill aquatic organisms living in water qualities. The frog in this photo was dead after the tunnel wash water, which contains large amounts of chemical pollutants. Another effect can be caused by roads is sediment and debris transport. Road failure can produce sources of both fine and coarse sediments. For example, surface erosion from roads can chronically contribute fine sediment in water bodies. The increased fine sediment in streams or rivers may reduce survival of aquatic insects and fish eggs. So, in face of wide acceptance of adverse effects of roads on environment and ecosystems, the concept of sustainability has become increasingly popular in road construction. Sustainable urban drainage systems refer to an interconnected network of green space and other environmental features, such as water bodies, to deliver ecosystem services to human beings. Sustainable urban drainage system contains a plenty of techniques, such as permeable pavement, swales and basins, and green roofs. In my project, I'm focusing on the stormwater ponds. Stormwater ponds control runoff quality and quantity by capturing and retaining stormwater runoff. the pollutants are removed mainly through sedimentation. The range of ponds range from 1 square meter to 2 hectares. And the road runoff can enter into the pond from this side. It will be stored in the ponds. Although sustainable urban drainage system can provide multiple ecosystem services, such as cool temperature, clean air, and store carbon, the heart of sustainable urban drainage system is the sustainable urban drainage system triangle, which includes 3 functions: water quality, water quantity, and biodiversity. Water quality and quantity refer to processes of mitigating peak runoff volume and road-related pollution. Biodiversity refers to the promotion and maintenance of organisms within one habitat. It's obvious that a good sustainable urban drainage system design should balance these 3 functions. However, currently, most studies only focus on the water quality and quantity functions. Biodiversity as a third side of triangle is normally neglected. In addition, due to the complex interactions between different ecosystems, it is still questioned that to which extent this system can support biodiversity. In order to maintain and promote aquatic biodiversity in stormwater ponds, the knowledge of factors that may affect biodiversity is of great importance. The potential factors can be classified. Factors include chemical pollutants in water quality volume and in sediments, as well as physical characteristics of stormwater ponds, such as pond area and age, as well as connectivity between different ponds. Biotic factors include vegetation and biological competition and predation. Currently, little is known about the complex effects on aquatic organisms resulted from interactions between different factors. Therefore, the aim of my project is to develop a model simulating the influences of environmental factors on the biological community composition, and to provide design recommendations for stormwater ponds. The objectives include to evaluate the impact of environmental factors, to identify the most important factors, to disclose the biodiversity in stormwater ponds, and to find out to which extent stormwater ponds can maintain and promote biodiversity. For now, I can only answer first 2 objectives, but I will. This presentation includes 2 appended papers. In the first paper, the relationship between aquatic organisms and water quality, as well as physical variables, were analyzed, and the most important variables were selected. And in the second paper, the aquatic organisms and the sediments were analyzed. So paper 1. In the first paper, 12 stormwater ponds situated along the highway E6 in the south of Norway were analyzed. The red dots here represent different stormwater ponds. And the 3 ponds here contains 2 separate small basins, one receiving runoff from an agricultural area and one receiving road runoff. In this study, I only focused on the one receiving road runoff. The data collected in the first paper includes aquatic organism, water quality, and physical variables. Aquatic organism and water quality data were collected in April, June, August, and October of 2012. And the physical variables collected once in 2012. The aquatic organisms include 91 microinvertebrates, 2 zooplankton, and 3 amphibians. 28 water quality variables, including chemical pollutants, such as metals, nutrients, and organic pollutants, pH value, conductivity, and dissolved oxygen were analyzed. 7 physical variables, including plant cover within and around the pond, were analyzed. And the rest of 5 variables were size and age of ponds, annual average daily traffic, number of neighboring ponds within a radius of 1 kilometer, and distance to the closest neighboring pond from study pond. Within the identified aquatic organisms, 4 microinvertebrate species and 1 amphibian species belong to vulnerable and near threatened categories of Norwegian Red List. The methods used in the first paper include unconstrained analysis, constrained analysis, and one-way analysis of variance followed by Turkey post hoc test. The principal component analysis was used to explore the general trends of water quality within and between ponds. It was also used to narrow down the variables that were used in the subsequent redundancy analysis. The redundancy analysis with forward selection was used to select the most important variables that contribute the most to the biological community composition. And the ANOVA by Turkey post hoc test was used to compare differences in water qualities between ponds. This is a result of RDA with forward selection. The red dots here represent different environmental factors, and the blue dots here represent different taxa of organisms. The triangle between red arrow and blue arrow means the relationship between organisms and environmental factors. If the angle is less than 90 degrees, that means they were positively correlated. If it's more than 90 degrees, then they were negatively correlated. So the results show that out of the 14 variables acted as the most important variables: size of the pond, chloride, metals, annual average daily traffic, distance to the closest pond, phosphorus, dissolved oxygen, and hydrocarbons. Within the physical variables, size of the pond has the greatest impact on the aquatic organisms, and most taxa were positively correlated with the size of the pond. And among water quality variables, on the aquatic organisms. The concentrations of chloride in our study were quite high in some ponds because sodium chloride is widely used in Norway as an de-icing agent. The increased chloride concentrations may lead to toxicity and harmful effects to aquatic organisms. For example, chloride deposition will release trapped metals from sediments, causing lethal toxicity to aquatic organisms. For the metals and the annual average daily traffic, most taxa were positively correlated with AADT and negatively correlated with metals. It was also demonstrated by other studies that the increases in heavy metal concentrations resulted in bursting.
Zhenua, we can't hear you. Can you turn the sound on?
I wonder if she's lost network connection. Oh,
Hi.
you're back. Did the network fail on you, Zhenua?
Oh, yes. Can you hear me?
I can hear you now.
Okay. I think the internet is not very good.
Are you using the Wi-Fi or you must?
Yeah, I'm using Wi-Fi because I work on my laptop.
Yeah. Sometimes the network cable is more secure, but it depends on where you are.
I'm in the meeting room.
Yeah, so it's probably not available. But I guess continue and see. Hopefully it'll hold out the rest of the presentation.
Okay, so where should I start?
I think you just finished chloride and then you could go on to the metals or
So still this slide, right?
yeah.
Okay. Chloride. So from chloride. Okay. So within the water quality variables, chloride has the greatest contribution to the aquatic organisms. The concentrations of chloride in our study were quite high in some ponds because sodium chloride is widely used in Norway as an de-icing agent. The increased chloride concentration may lead to toxicity and harmful effects on aquatic organisms. For example, chloride deposition will release trapped metals from sediments, causing toxicity to aquatic organisms. And for the metals and annual average daily traffic, most attacks were positively correlated with annual average daily traffic and negatively correlated with metals. It was also demonstrated by other studies that increases in metals resulted in the decrease in biodiversity. And for the result for the ADT is a bit unexpected because more traffic was expected to generate higher concentrations of pollutants in road runoff. However, in our study, the ADT was highest in the areas with the largest pond. So dilution could play an important role in reducing the concentrations of pollutants in the stormwater ponds. In addition, most attacks were negatively correlated with the distance to the closest pond. That means the shorter distance between two ponds could support more biodiversity due to the higher connectivity between them. And regarding phosphorus and dissolved oxygen, some texts were positively correlated with them, and some were negatively correlated. The dissolved oxygen concentrations in our study were relatively low than the threshold value that were relatively high. So it doesn't appear to be the major limiting factors. And compared with other selected variables, hydrocarbons has the least contribution to the biological community composition. So paper 2.
Zhenua?
Yeah?
I'm sorry for interrupting you, but none of us can see your presentation. Can you please share your screen?
Oh, I shared my screen.
Yes, we can only hear you speaking now. Can you please share your desktop?
Okay. Can you see it now?
Yes, thank you very much.
Oh, so where should I start now?
It's okay, just continue.
Okay. In paper 2, in addition to 8 ponds that have been analyzed in the first study, 4 new ponds were included in the second paper in order to increase the geographic range of ponds and range of pond age. So one stormwater pond, which located in Oslo, is an urban pond, but it also receives road runoff. And the rest ponds are situated along major highway E6 and E18 in south of Norway. The data collected in the second paper include aquatic organisms and sediments. The aquatic organisms were collected in April, June, August, and October in 2013 and 14. The sediments were collected once in 2013 and 14 respectively. The aquatic organisms include 176 microinvertebrates and 5 amphibians, and 11 pollutants in sediments were analyzed, including metals, pH, total hydrocarbons, and total organic carbon. 4 microinvertebrate species and 1 amphibian species are red listed, belonging to data deficient, vulnerable, and threatened categories. And compared with the organisms in the first paper, there were much more taxa in the second paper, because more organisms were identified to the species level. And also the data used in the first paper only collected from 1 year, 2012. But the data used in the second paper were collected from 2 years, 2013 and 14. And the method used in the second paper include unconstrained analysis and constrained analysis. The principal component analysis were used to explore the general trend of pollutants in sediments. And redundancy analysis were used to analyze the influences of pollutants in sediments on aquatic organisms. This is a result of RDA analysis for pollutants in the sediments. Similar to the first one, the red arrow here represents different pollutants in the sediments. And the blue arrow here represents different taxa of organisms. And the angle between blue arrow and the red arrow means the correlation between them. And the results show that different taxa responded differently to pollution. And some taxa were positively correlated with these 4 pollutants, and some were negatively correlated with them. Within the taxa that were positively correlated with total organic carbon, some of them have been proven to be highly tolerant to organic enrichment, and some of them, such as filter feeding microinvertebrates, could feed on total organic carbon in sediments, which act as sources of nutrients. For the metals, some species and families from mayflies and caddisflies were positively correlated with metals. Although mayflies, caddisflies, and stoneflies are normally sensitive to organic enrichment, they may exhibit high tolerance to metals. And within the rest taxa that were positively correlated with metals, some of them are metal-tolerant species. In addition, the concentrations of most toxic metals, such as lead and nickel, in our study were relatively low, and most of them were categorized as good or high ecological status. And regarding total hydrocarbons and the pyrene, the majority fraction of total hydrocarbon in our study were heavy hydrocarbons. The carbon ranges from 21 to 40, and this kind of hydrocarbons are less toxic to aquatic organisms compared with the light hydrocarbons, because heavy hydrocarbons have lower solubility and mobility in water. Although pyrene is one of the most toxic organic pollutants, all measured concentrations of pyrene in our study were below the threshold value that can cause acute toxicity to aquatic organisms. So this could explain why some taxa were still positively correlated with pyrene. Getting to the conclusion, in the first paper, I have found that the pond size plays an important role in affecting biological community composition. And bigger ponds may promote and maintain more biodiversity due to the species area effects and dilution of harmful pollutants. The second paper showed that it's crucial to identify organisms to the species level because the responses of different taxa to the pollutants, even within one family, could be different. Moreover, several factors may affect the bioavailability of pollutants in the sediments, in addition to the effect of each pollutant on the biological community composition. The complex interactions between different pollutants should be also considered. And more work are still needed for the second paper. The characteristics of organisms and biological interactions will be analyzed in the next step. So in the future work, I'm going to use MET barcoding. The toxicity identification in previous studies was done by observation of morphological characteristics. Normally, it's very difficult to identify organisms to the species level due to the lack of diagnostic morphological characteristics at the level, especially for people who don't have relevant experience and knowledge. And even for experts, it may take a long time to identify samples only to the genus level. MET barcoding allows the rapid and cost-effective assessment and monitoring of biodiversity. It can also identify organisms to the species level and compensate for the disadvantage of traditional methods. I'm also going to use process-based models in the future work. Statistical models are widely used in different areas of study. However, statistical models are not appropriate methods to understand issues in great depth because they cannot simulate different processes involved in the whole environment and ecosystems. Process-based models can be established based on a set of equations describing different processes. It can also help us to understand the underlying mechanisms behind the processes. So thank you very much for your attention. And do you have any questions?
Are there any questions for Zhenua? Okay, I don't think there are any questions, Zhenua, so thank you very much for your presentation.
Okay, thank you.
Thank you.